So yesterday we talked about semi-log plots and graphing exponential functions on a semi-log plot. Made it look linear. We could get information from it that way. Today we're going to be talking about other kinds of modeling. Okay, today we're talking about linear and quadratic modeling. And here's the premise. What if we are given a set of data and we don't know what type of function it is? Maybe it's exponential, maybe it's logarithmic, maybe it's linear, maybe it's quadratic, cubic, quartic, quintic. There's a lot of different functions that could model a set of data. So we are going to today be finding a function that models a set of data. Okay, this is a very useful technique to have in your hands. This is something that engineers and scientists have to do frequently. When they get a set of data, they have to find a model for it so that they can predict what best things to do for their purposes. We are going to be using they use software, computer software. We're going to be using our calculator. So what we're going to be doing today is building regression models on the TI-84. Specifically, we're going to be doing linear and quadratic today, but everything that we're doing today can apply to any other type of regression model that our calculator can do. So this will probably be our last video for the notes because everything else will just be examples. Alrighty, so to build a regression model on the TI-84, 2 steps. Enter the data and then select your regression model. So step 1 is to enter your data. So on your calculator, and I'm going to be using, let's use the first set of data, the first examples, the set of data from our first example over here. So I want to enter this data into my calculator. So first thing you're going to do is you're going to go to your stat key on your calculator. Go to your stat key. In fact, I might just show you on this. We're going to go to our stat key. I'm going to turn on the calculator. We're going to go to the stat key. The stat key is right here. Okay, hit stat. We get that screen. I would like to enter, I'm going to enter the time, and for L1, that'll be my list for time, and L2 will be my weight. Let's go ahead and read this. I should have read this to you. The age and weight of 5 randomly selected babies from a particular pediatrician's office are listed in the table. Okay. A linear regression is used to construct a linear model L, where T represents the age in weeks of the baby and L of T represents the weight in kilograms. So we're going to let time, age be L1 and the weight be L2. All right. So get this to where there's not as much glare. Alrighty, so I'm going to select edit because I want to add these numbers, these values to my lists. So I'm going to just hit enter. And now I have an old set of data in here. I want to get rid of it. So the easiest way I know of to get rid of it is to press delete. I'm highlighting there. Press delete, and I'm just going to hold down delete until this side is all clear. Hold it down and it's done. Go to the other list, hold down delete, and it's gone. Now I can input my other L1 values, so 4, 5, 6, 8, and 12. You guys, you have to hit enter after every number or else it's not added to your list. So hit enter, especially on that last one. That's the one students tend to miss. So hit enter, enter, enter each time. Now I'm going to go to L2 and enter the weights. So 4.2, 4.4, 4.8, 5.1, and 5.7. Hitting enter after each one. Okay, now this is stored in for L1 and L2. Okay, in this problem, we have a linear. We want a linear model. So it says a linear regression is used to construct a linear model, L. Okay, so we want a linear regression. So I'm going to go back to my stat button, go to your stat key, and I've already entered it all. I want to go over to calc, so scroll over to calc, and I want a linear regression model. So there are two linear regression models that this calculator has. One of them is number 4, and one of them is number 8. They're both linear regression models. You can see the difference, and there's very little difference. One of them just has the x come first, and one of them has the x come second. Okay? They will both work, and they will both give you the same answer for our purposes. I will tell you that AP Stats uses 8, so I'm going to use 8 here, but you can use either one and it's fine. Alright, so I'm going to go down and hit number 8. Okay, when I hit number 8, this is what I get. My calculator automatically puts in L1 and L2 for the X list and the Y list. I like that. I'm not changing it. That's just it. So I'm going to leave that in there. If your calculator does that automatically, great. If not, you are going to have to type in L1 and L2. L1 and L2 are in blue above the 1 and the 2 keys. So you'll have to do second 1 to get L1 and second 2 to get L2. FYI. Alrighty? Now, I don't put anything in for a frequency list, but I do go over and to store the regression equation. I want to store the regression equation in for my Y1, in my Y equals screen. So I'm going to put Y1 up there, and Y1 and Y2 and Y3 and all the Y's are found, the easiest way to get there is to use the F4 button. So I'm going to do alpha, F4, and there's all of my Y's. So I can just hit 1 for Y1, and then I'm going to go to calculate, and as soon as I hit calculate, it will pop up for me. Okay, so linear regression. This is the linear regression model, and they want me to write the equation of L of t. So L of t, I can write, would be A, which is 3.545, plus B, which is 0.185. Now, this has an X. They are telling me to make it a T, so I will make it a T. If they want a T, I'll give them a T instead of the X. Okay? Part B is to use L of t to predict the weight of the baby that is 10 weeks old. So now, since we stored L of t, since we stored our line in for Y1, if I hit Y1, there it is. It already stored it in there for me. Okay? So, let's set an appropriate window for this. I don't know what your window has in it, but mine has, clearly I did Zoom 4 last, because that's the Zoom 4 screen, the Zoom 4 window. My age. I'm going to start my age at 0, and end my age. I would like to go a little bit past 12. I might go all the way to 24. Why not? 24 weeks. Okay? For my X scale, that's how many how often I see a hash mark on the X axis. Since I'm going from 0 to 24, I might just go every 5. It doesn't really matter, but I might just go every 5. Okay, for my Y min and Y max, my lowest weight is 4.2. I think I might start my Y min at 4 because the baby's, you know what? I might start it at 0. Why not? why not start it at 0? Here, it's close enough. And then for my Y max, since I'm going to 24 weeks, I might go more than this, than my maximum weight listed in the table. I might go to, I don't know, 10, something like that. Okay, something like that. Let's see what this graph looks like now. All right, so X is going from 0 to 24, and I could trace this. Now, if I wanted to see these points, I would go to stat plot, and it would turn on the very first. If I go to stat plot, and if I turn plot 1 on, it will also graph those points. I'll show you what that looks like. I don't do this, but I will show you what that looks like. I'm going to turn this on. Oops, I'm going to turn this on. Now if I go to the graph, we see those points on there also. Okay? Truly, I don't need those points, and it's just going to make using this line harder, so I'm going to go back to my stat plot and turn that off. I really don't need to see those points. Alrighty, so let's answer this next question. Use L to predict the weight of the baby that is 10 weeks old. Two ways I can do this. I can trace until X is 10, and I can just hit 10, and it'll go straight there. This is Y is the weight when X is 10. So the weight would be 5.39, I'm sorry, I can't read. There's a glare here. Is that a 2 or a 3? It is a 3. 395, I was right. Okay, what would be the units on that? That was in kilograms. So a 10-week-old baby is expected to weigh this amount. The other way to do that is not on our graph, but on our home screen. If I go to my home screen, second quit, home screen, and I go to Y1, remember Y's are in F4, Y1 at 10. And that also will give me the same value instead of using the trace feature. Okay? The weight of a sixth baby is 5.3 kilograms. Using L, how old is that baby? Well, on the graph, there's my graph. I would like to see how old a baby is that is 5.3 kilograms. If I also graph 5.3, that will be a horizontal line, right, when Y is 5.3. And I can just find the intersection X value. So second calc, intersect is number 5, enter, 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 and that baby would be 9.486. I'm going to give 3 places after the decimal point, and that would be in weeks. Alrighty. Let's do another one. The table here shows the population of a city every 10 years since 1970. Is a quadratic or linear model the best fit for this data? Is a quadratic or linear model the best fit for this data? Okay, well, let's find out. Alrighty. Okay. So using the steps that we just did, that will determine any regression model that we want. I could have gone in under Calc and chosen any one of these regression models. It sure did look linear, but if I wanted to, I could do the same thing with a quadratic model, and it would give me a quadratic model that best fits that data. The question is that model better or worse than a linear model? Well, the stat plot, if I go and turn that on again, the stat plot sure did look linear. However, who knows? Maybe it could have been some other curve as well. So which is best? That's people would like to know that. I want the best fit model for it. So we need to find out which is best. How do you know which one is best? Well, under mode, if you go to your calculator, under mode, if you come down under to stat diagnostics is by default off. I don't know why, but it is. It's by default off. We are going to turn it on. So go over, push enter on, so that your stat diagnostics are on. Okay? Alrighty. So now that that is on, let's come in and let me go back to that linear, let's go back to that linear regression model. So stat, calc, linear, I'm going to go down to number 8. Enter, enter, enter. I've already done with that problem, so I'm not going to bother restoring. I'm not going to restore it in for Y1. Okay, now we see more on the screen. We had the first 3 lines before, and now we see more. This r squared is where you want to focus on. The r squared is, the closer that r squared number is to 1, the better this model is. So let me just do a little scratch work here. For linear, the r squared model gave us 0.96954. Let's do the same thing now for quadratic. Stat, calc, number 5. Enter, 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 enter. What is its r squared? Its r squared for quadratic is 0.9906. That is closer to 1 than the linear model was. That tells me that this would be better suited as a linear regression. Let's go see what that curve would have looked like had I made this quadratic. Okay, y1. Now I have a completely different equation in for y1, and I'm going to keep the same window because it still suits that data. And this time I'm going to turn, okay, my stat plot is still on, so it's going to show this. Oh, well, doesn't that look like a better quadratic model for that set of data? Now, realistically speaking, that's a little concerning, because that tells me that this baby is going to start decreasing in weight, or that the babies will start decreasing in weight. That's a little concerning. So sometimes we have to use our logic to determine which set of data is right. Let's take a look at number 2 here. Number 2 shows the population of a city every 10 years since 1970. Is a quadratic or linear model the best fit for this data? Well, let's find out. We're going to go in and put new data in. So I go to Stat, Edit, clear out what's there by pushing Delete on my list, put in our new data. So 0 would be 1970, 10 would be 1980, etc., right? So I'm just going to put in the numbers they gave me, 0, 10, 20, 30, and 40. 489, and this is in thousands of people, but I'm just putting in the exact numbers that they gave me in that table. Making sure to hit enter at the very, very end. Okay? All right, stat, calc. Let's do linear first. Let's see how good it is. So I'm going to do number 8. Enter, enter, enter. I'm not going to put it in for y1 yet, not until I know which one is best. So linear gave me r squared is 0.947. That's pretty good. What does quadratic give us? Quadratic gives us, so stat, calc, quadratic is number 5. Quadratic gives us r squared is 0.99879. That's even better. So I'm going to use the quadratic. That's all I have to go on for this problem. So I am going to go back. I'm going to store that in for, I'm going to store y1. I'm going to store this equation in for y1. So second F4, y1, enter, enter. It's the same thing I just saw, except now in for y1, I have that. I don't need this 5.3 anymore. I'm going to clear that. Okay, let's go to our window. Let's see what window we could use here. What would be a good window for this one, to where there's no glare. All right, for my x's. So for my x's, I'm going to start at 0. That was 1970. And it goes through 40. I like to go a little bit past it. I might go to, I don't know, let's go to, in the problem situation, they ask me about 2030. This is 1990, this is 2000. 2030 would be, what would 2030 be? 2030 would be 60. I think I might just go to 70. And I'm going to put hash marks every 10 years. Okay. The y min, I'm going to make the y min maybe 400. And the y max, I don't know. How about 4,000? Is that too much? Too little? I don't know. I might put hash marks every 100. Oh, I still had my stat plot on. Well, I kind of like having my stat plot on for the moment because I can really see the points here, and they do look. I can see why a linear was a possibility, but these do look the quadratic. Okay. So quadratic model is best. For these points. I really don't like to see, I don't like to see that stat plot on, so I'm going to go in and turn that off. So I just have the curve and no points. All right. Using the model determined from part A to be the best fit for this data, determine the projected population in 2030. 2030. So two ways to do it. Trace to 2030. Okay. Oh, I know what I did. Okay, go back to your graph. I traced to 2030. I want to trace to 60. It won't trace to off your graph. So there is the trace when we're at 20 in 2030, where this value is 60, right? So it would be 5639.4, but it's in thousands of people. So it would be 5,639,400 people. That would be the population. Using the model determined from part A, approximate the year when the population was 2,500,000. So I'm going to be looking for, in fact here I might say y was equal to 5639.4, just for the sake of your notes. Here I want x to be, I want y to be 2,500, yeah? I want y to be 2,500. So now I'm going to go to my y equals, put 2,500 in for y2, see where they intersect, second calc intersect, enter, 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 and that was when x was 35.605. What year was that? What year was 35.605? That would be 2005. Yeah? Yeah. Okay. So we're getting information from the graph for this model. Okay, let's do one more example here. Okay, a pumpkin tossing contest is held each year in Morton, Illinois, where people compete to see whose catapult will send pumpkins the farthest. One catapult launches pumpkins from 25 feet above the ground at a speed of 125 feet per second. The table shows horizontal distances in feet the pumpkins travel when launched at different angles. I'm going to make L1 my angle and L2 my distance. We could, if we wanted to, reverse those, okay? No, but we could, we would have to be in a different calculator. Not in my TI-84. I can't reverse those. Okay. Part A. Determine if the data is best represented by a linear or quadratic model. So, let's see. I'm going to go to my stat. Edit. Clear out what's there. Put in the new stuff. I always take a look at those numbers and make sure I put them in correctly. Okay, it would kind of stink to make an error putting numbers in and then all of your answers are wrong. Okay, stat, calc, we want to know which is better, linear or quadratic. So I'm going to do number 8 for linear. The r-squared value for linear is very low. Probably not a good model for this one, not even close to 1. That number is always going to be between 0 and 1. So let's look at quadratic, number 5. That r-squared is very close to 1. So of these two, the best fit is a quadratic model. Okay, then we have some questions to answer. So let's now go to the graph. Okay, what best window should we use? Well, these are angles. I'm going to go from 0 to 90 degrees because the catapult is not going to be set in anything less than 90 degrees. Or anything more than 90 degrees. And then for my distance, I might go from 0. Oh, the scale is set on 10, that's fine. 0 to, it looks like the highest distance was somewhere in the 500s. I might go to 600 just to see a nice curve. So I'm going to go to 600. That scale is on 100, that's fine. I'm just going to leave it like that. Oops. Well, something is off here. What did I do? My window is clearly off. I never did save that in for my, Y1, so I'm going to go to number 5. This time I'm going to save it in for Y1. This should be better. And it is. Ooh, I did a good job on my numbers in my window. Okay, Really nice job there. Okay, so how far does the pumpkin go if the angle is 57.8? Trace 57.8. How far does it go? It goes 455.422 feet. Okay, what angle was the catapult set at when a pumpkin went exactly 400 feet? So y equals 400 feet There are two angles that produce a distance of 400 feet. Second calc 5, that looks close to 200. Oops, second calc 5, enter, enter. Now that looks close to about 200. Well, second calc 5, enter, enter. I'm just going to scroll this time. Enter. So it was set at 22.593 degrees, and second calc 5, enter, second calc 5, enter, enter, goodness, enter. Okay, and that one was set at 63.821 degrees. I think that's 63. There's a little glare on my calculator. Okay. What angle should the catapult be set at to produce the farthest distance? Well, the farthest distance would be right there. So we want the maximum distance. So second calc maximum is number 4. It's asking me for my left bound. Hit enter on the left. And now my right bound, hit enter on the right. And now my guess, I'm just going to hit enter a third time. So what angle is that at? It is 43.207 degrees. So the person who owns this catapult should set it at that to get the farthest distance for his pumpkin tossing. All right. Very enjoyable, satisfying work today. Tomorrow, we'll just be doing some examples because this same process can be used for any of our various regression models.